Welcome to Eternal Vault, a journey through science, history, and the mysteries of the universe. Here, every story uncovers hidden layers of truth, every fact connects us to something greater, and every discovery pushes the boundary of what we thought we knew. From the deepest past to the farthest stars, this is Infinite Archive where knowledge never ends. We all know the picture, the sun, a perfect fiery anchor at the center of a clockwork system of orbiting planets. It's the heliocentric model, a triumph of human reason over ancient belief, championed by Copernicus and cemented by Galileo. It's simple, orderly, and feels fundamentally correct. It gives us a sense of cosmic stability. But this classic image is a beautiful lie, a necessary simplification that gets the basic idea right but misses the breathtakingly complex truth. What if I told you the sun isn't stationary, that it's constantly wobbling, swaying, and spiraling through space, and that right now, you are not orbiting the center of the sun? This isn't a flaw in our understanding. It's the next layer of the cosmic onion. The truth is far more fascinating. The secret to this motion lies in a single, invisible point in space, the true center of gravity for our entire solar system. This is the story of the barycenter, the gravitational heart of our solar system. And understanding it doesn't just change our model of home. It's the key to finding new worlds across the galaxy. Our journey to this deeper truth begins with the models we had to overthrow. For millennia, the geocentric model, perfected by Ptolemy, placed Earth at the immutable center of creation. The heavens, fixed to crystalline spheres, revolved around us. It was a universe designed for humanity. The Copernican revolution was a profound demotion. It ripped Earth from the center and placed the sun there instead. Later, Kepler's ellipses showed the orbits weren't perfect circles, and Newton's laws revealed the invisible thread, gravity, that bound everything together. But in embracing this new truth, we unconsciously clung to one last piece of our old thinking, the need for a fixed center. We pictured the sun as a static gravitational monarch, with planets circling it like obedient courtiers. Yet Newton's own third law, every action has an equal and opposite reaction, tells us otherwise. If the sun pulls on Jupiter, Jupiter must pull back on the sun with equal force. The sun's movement may be tiny compared to Jupiter's, but it is never zero. This insight would eventually complete the Copernican revolution, realizing that even the sun must dance. To grasp this, we need to stop thinking of a center and start thinking of a balance point. In physics, for any system of orbiting bodies, that point is called the barycenter, from the Greek baris, meaning heavy. It's the precise point where masses balance each other out. Think of a seesaw, two kids of equal weight balance in the middle. Add a sumo wrestler on one side and a child on the other. To balance, the fulcrum shifts closer to the wrestler. Both still move, but in different arcs. Now scale this idea up. The Earth-Moon system has its barycenter 4,671 kilometers beneath Earth's surface. Earth itself makes a subtle monthly wobble as it responds to the Moon's pull, an effect that contributes to ocean tides. Even Pluto and its moon Charon are a dramatic example. Charon is so massive relative to Pluto that their barycenter actually lies outside Pluto's surface, making them a true binary dwarf planet system. If the Moon and tiny Charon can force entire worlds into a wobble, what kind of dance must the solar system's giant planets demand from the Sun itself? The Sun is the undisputed monarch of mass, holding 99.8% of all the matter in the solar system. But Jupiter is the court jester who refuses to let the king sit still. Jupiter is more than twice as massive as all the other planets combined. Its gravitational handshake with the Sun is staggering. Jupiter orbits about 778 million kilometers from the Sun. The Sun is about 1,047 times more massive than Jupiter. Their barycenter lies roughly 740,000 kilometers from the Sun's core. The Sun's radius is only 696,000 kilometers, which means the Sun-Jupiter barycenter lies outside the Sun itself. In other words, the Sun is not the fixed pivot point. It loops around an invisible point in space, tracing a circle about once every 11.86 years. Jupiter doesn't orbit the Sun's center. They both orbit the barycenter. This is the Sun's great cosmic dance. It is not a monarch enthroned, but a dancer pulled by its partner. Jupiter may lead, but it doesn't dance alone. Saturn, Uranus, Neptune all exert their gravitational influence. The result? The solar system barycenter constantly shifts like the center of a restless spinning top. When planets spread out, their pulls partly cancel, and the barycenter drifts closer to the sun's interior. When the giants align on one side, their combined tug is enormous. In the early 2020s, during one such alignment, the barycenter drifted over 810,000 kilometers beyond the sun's surface, further out than the sun's own diameter. The sun's path, therefore, is not a neat circle, but a looping, spiraling, jittery track around this ever-moving point. Some astronomers liken it to the sun drawing a spirograph pattern as it sails through the galaxy. Intriguingly, this dance may even influence the sun's inner workings. A controversial but fascinating idea is that planetary alignments could subtly affect the solar dynamo, the engine that drives sunspots and solar flares, possibly modulating the famous 11-year solar cycle. If true, planets aren't just orbiting the sun, they're shaping its temperament. This principle, that planets cause their stars to wobble, has become one of the most powerful tools in astronomy. We can't see exoplanets directly, but we can see their parent stars move. The radial velocity method detects a star's tiny back-and-forth tug through the Doppler effect. Its light shifts blue when moving toward us, red when moving away. The size of the wobble reveals the planet's mass, and the rhythm of the wobble reveals its orbital period. This method found the very first exoplanet orbiting a sun-like star, 51 Pegasi b, in 1995, a discovery that won the 2019 Nobel Prize in Physics. Another method, astrometry, tracks the star's tiny sideways drift against background stars. Though challenging, it's now being revolutionized by ESA's Gaia mission, which is charting the positions and motions of over 1 billion stars, expected to reveal tens of thousands of new worlds. As of 2025, astronomers have confirmed over 6,000 exoplanets, with thousands more candidates awaiting confirmation. Nearly all of them were found by detecting the barycenter dance of their stars. Our sun's wobble isn't unique. It's a universal fingerprint of planetary systems. Every wobbling star is whispering the presence of hidden worlds. Our sun, while looping around its shifting barycenter, is also hurtling through the Milky Way at about 828,000 kilometers per h, 514,000 miles per hour. The sun's own dance layers atop this grand orbital journey around the galactic center, which takes 250 million years per lap. So picture this. The entire solar system is not just moving, it's spiraling, bobbing, and weaving as it races through the galaxy. The sun's barycentric loops trace out a kind of cosmic calligraphy, carving patterns in space-time itself. From the largest scales of galaxies down to binary star systems and moons orbiting planets, the barycenter principle is universal. It is gravity's democratic rule, where no mass, however mighty, escapes the push and pull of others. Let's erase the textbook image for good. The sun is not a fixed anchor. It is a dancer, tracing graceful looping spirals around an invisible, ever-shifting point, the barycenter. This is the true nature of our cosmic home, a gravitational democracy, where every world, from giant Jupiter to tiny Pluto, casts its vote in the collective motion. And this principle stretches across the cosmos. It is the reason we can find other worlds, the reason we know planetary systems are common, and the reason we can dream of habitable planets orbiting distant suns. The barycenter isn't just a piece of astrophysical trivia. It's the universal rhythm of creation. Every wobbling star is a silent beacon, guiding us to new worlds and reminding us that in the grandest sense, the universe itself is always dancing.